4 volcanoes, 1 archipelago, all of them active at the same time. Mayon, Taal, Bulusan, Kanlaon. Right now, as you watch this, all 4 are on active alert status in the Philippines. Volcanologists have no recent documented precedent for this. 4 simultaneous alert levels across a single island nation, a convergence that has no modern parallel in the Philippine record. And then, on February 19, 2026, one of them exploded. But here is what nobody is telling you about that explosion. The scientists did not miss it because the volcano was too quiet. They saw it coming in a signal that looks like silence. In the days before the blast, Kanlaon stopped breathing. Sulfur dioxide output, which had averaged 2,823 tons per day since June 2024, collapsed to 174 tons per day immediately before the eruption. The gas disappeared. That is not a malfunction. That is not a calm period. That is a volcano sealing its own conduit, locking pressure inside a closed system, and building toward an explosion that instruments cannot stop and evacuations can barely outrun. This is the mechanism nobody explains. This is the signal buried in the data. And right now, on an island of 4,150 people living inside the hazard zone, that signal has fired again. At 4:38 p.m. local time, the trap was sprung. A dark gray eruption plume detonated 2,000 meters above the summit crater before winds bent it southwest toward populated communities. Pyroclastic density currents, superheated mixtures of gas, ash, and shredded rock moving at hurricane speed, descended the southern and southwestern flanks. On the southwest side, they flowed for at least 2 kilometers downslope. The eruption itself lasted 2 minutes. 2 minutes. Then came 40 more minutes of continuous ash emission that blanketed 41 barangays across 6 cities and municipalities in Negros Occidental. A shockwave radiated outward. Residents in La Castellana, Moises Padilla, Pontevedra, San Enrique, and Hinigaran felt the ground tremble and the air compress. An infrasound station roughly 4 kilometers from the crater recorded a peak pressure of 225 pascals. The smell of sulfur reached communities that never smelled sulfur before. Over 30 families have already been evacuated from La Carlota city alone. A sulfuric haze hangs over towns that were going about a normal Thursday afternoon. Think about what that means. People eating dinner, kids returning from school, farmers checking their fields, and then, without a crescendo, without days of visible warning, a gray column rises 2,000 meters into the sky and starts moving toward them. The ashfall reaches 41 communities. The shockwave compresses windows, the sulfur smell enters homes, and the official bulletin arrives 4 minutes after the eruption begins, at 4:42 p.m., because there was barely time to write it. This is Kanlaon operating at full efficiency. Silent, then catastrophic. To understand why this keeps happening, you have to go back to June 2024. That is when Kanlaon crossed a threshold. On June 3, 2024, the volcano produced its first moderately explosive eruption in years, a 5,000-meter plume. Pyroclastic flows racing down the south and southeastern slopes. Sulfurous odors reported 85 kilometers away in Bacolod. 5 barangays immediately evacuated. 57,563 people ultimately affected by that single eruption, with 3,905 displaced from their homes and 2,680 houses damaged. That eruption was not a reset, it was an opening statement. In the months that followed, the mountain never fully calmed. September 2024 brought a series of volcano-tectonic earthquakes. Then on September 10th, Kanlaon produced its highest single-day sulfur dioxide output since 2009, 9,985 tons. The record lasted 1 day. On September 11th, it shattered its own record, 11,556 tons of sulfur dioxide emitted in 24 hours. PHIVOLCS raised concern about the possibility of the first fully magmatic eruption since 1902. Then, December 2024. Another explosive eruption, a shockwave visible across the islands of Panay, Guimara, and Cebu. Around 40,489 people affected across the Visayas. Agricultural losses of $681,314. Then, October 2024, before that, 28 separate ash emission events in a single day, lasting between 4 minutes and 1 hour and 18 minutes each. This is not a volcano between eruptions. This is a volcano in a continuous state of eruption, cycling between explosive releases and temporary silence. And the silence is the most dangerous part. Here is the detail buried in the official bulletin that changes how you read all of this. PHIVOLCS did not call today's eruption a surprise. They called it a repeating mechanism. Since June 2024, Kanlaon has been operating on a closed cycle. Gas builds. Pathways seal. Pressure exceeds the mechanical strength of the rock. The volcano explodes. Then it vents. Then the pathways seal again. The cycle resets. This was the 6th moderately explosive episode in under 2 years. And each time, the warning window shrinks. The sulfur dioxide drops. The edifice swells. GPS and tilt sensors record short-term inflation. This latest episode of swelling began in late January 2026. And then the mountain fires. The data shows an edifice that has been slowly inflating since 2022 due to deep magma intrusion. The implication? The pressure source is not going away. It is growing. Each eruption is not a release of the underlying problem. It is a punctuation mark in an ongoing sentence the mountain is still writing. Most people watching this live within range of a fault line or active volcano. You probably do not know which one. Comment your country. Now consider the geometry of that sentence. 2022, ground starts swelling. 2024, first major explosion, then 5 more explosions in 20 months. Each one triggered by the same mechanism. The conduit closes, the sulfur dioxide collapses, the pressure builds, the system breaks. PHIVOLCS has watched this cycle repeat and documented it in detail. The mechanism is understood. The hazard is understood. What is not understood is how many more cycles remain before the system crosses a new threshold, before a 7th eruption is not moderate, but something else entirely. That is the question the monitoring data is trying to answer in real time. Now widen the frame, because Kanlaon is not erupting alone. Mayon volcano, 350 kilometers to the north in Albay, has been in continuous eruption since January 1st, 2026, when PHIVOLCS raised its alert to level 3. This is not a dormant volcano showing signs of life. This is a machine running at sustained high output. From January 1st to February 9th, instruments recorded 9,941 rockfall events, 1,690 pyroclastic density currents, and 1,346 volcanic earthquakes. Sulfur dioxide emissions peaked at 6,569 tons in a single day on February 4th. By February 8th, lava flows had extended to radial distances of 1.3 kilometers on the Mi icy drainage to the south, 1.6 kilometers on the Bonga drainage to the southeast, and 3.8 kilometers down the Basu drainage to the east. 3 active lava channels. Simultaneous pyroclastic density currents. Nearly 10,000 rockfall events in 40 days. Mayon is not resting. Mayon is accelerating. And Mayon has history. Its most destructive recorded eruption buried the town of Cagsawa and killed over 1,200 people in 1814. It has erupted more than 52 times in 500 years, making it the most active volcano in the Philippines. When Mayon is at alert level 3 and producing output measured in thousands of tons of sulfur dioxide per day, the 6-kilometer permanent danger zone around its base is not a precaution. It is a necessity. Meanwhile, Taal volcano south of Manila, sitting inside a lake, 70 kilometers from one of Southeast Asia's most densely populated metropolitan areas, remains on active monitoring status. Taal's 2020 eruption displaced hundreds of thousands of people and produced a volcanic lightning storm visible from Manila. The population within its hazard zones has never fully recovered to pre-2020 distribution. And Taal does not need to erupt catastrophically to cause mass disruption. It simply needs to elevate its alert level, and the economic and logistical consequences cascade across the entire southern Luzon region. As recently as February 1, 2026, the National Disaster Risk Reduction and Management Council was issuing combined 24-hour observation summaries covering all 4 volcanoes simultaneously: Taal, Mayon, Bulusan, and Kanlaon. 4 volcanoes, 1 archipelago, 1 ring of fire. Bulusan has since been walked back to alert level 0 as of early February, its seismicity returning to baseline. That is the one data point that softens the picture. But the larger pattern does not dissolve with one calmer reading. Bulusan has erupted 15 times since 2016. It has a documented history of sudden, steam-driven explosions with minimal warning. A return to alert level 0 means quiet today. It does not mean quiet tomorrow. PHIVOLCS Director Teresito Bacolcol was direct in a public statement. The simultaneous activity of multiple Philippine volcanoes does not indicate a physical connection between their magma systems. Each volcano has its own independent plumbing. The Philippines sits on the Pacific Ring of Fire, home to 24 active volcanoes, and the statistical probability of 2, 3, or 4 showing activity simultaneously is real and non-trivial. That is the official position. It is grounded in the science of volcanic plumbing, separate magma chambers, separate conduits, separate histories. But there is a second framework circulating among researchers and in peer-reviewed literature on stress transfer. The Philippines has been experiencing significant seismic loading in recent months. Magnitude 7.4 events in Mindanao, a magnitude 6.9 near Cebu. Tectonic stress does not respect the administrative boundaries between volcanic systems. It propagates through the crust. It redistributes load. Whether that redistribution is materially changing the eruption probability of volcanoes in delicate equilibrium is an open and actively studied question. The mechanism being considered is this. Large regional earthquakes can transfer static stress through the lithosphere, potentially destabilizing magmatic systems that are already close to their critical threshold. The key phrase is already close. A volcano sitting comfortably inside its equilibrium range does not respond to a distant earthquake. But a volcano that has been inflating for 4 years, cycling through explosive eruptions, with its conduit repeatedly opening and sealing, that volcano may be sitting precisely at the margin where a small perturbation produces a large response. Kanlaon has been at that margin since 2022. Mayon reached it in late 2025 when rockfalls began accelerating toward the peak of 47 events per day recorded in December. The question of whether regional seismicity is nudging these systems, or whether the timing is statistical coincidence, is not a question that can be answered with today's monitoring tools alone. The official answer is, probably not. The data-driven concern is, we do not yet know. And in the space between those two positions, 4,150 people live within the extended hazard zone of Kanlaon alone. Back on Negros, the immediate threat is not the eruption itself. It is what comes after. The upper slopes of Kanlaon are now blanketed with fresh, unconsolidated ash and pyroclastic material. Loose, unstable, waiting. The deposits from today's eruption join layers of material from the December 2024 eruption, from October 2024, from the June 2024 blast. Each cycle adds new material to slopes that are already saturated with volcanic debris. Each cycle brings more fuel for what comes next. The monsoon season is not far off, and even a single heavy rain event can mobilize that material into lahars, fast-moving rivers of volcanic debris that follow drainage channels with no warning and no escape. This is not a theoretical hazard. In June 2024, rains triggered lahar flows in La Castellana just 2 days after the first major eruption. The communities downstream of Kanlaon's major drainages have been warned. They have been warned before. The lahars came anyway. What makes the lahar threat qualitatively different from the eruption itself is the timing window. An explosive eruption at Kanlaon lasts 2 minutes. A lahar event following heavy rainfall can arrive hours or days after the eruption, when communities have started to relax, when the immediate evacuation has been stood down, when people have returned to check on their homes and animals. The volcano fires. People react. People return. Then the rain comes, and the mountain follows them home through the drainage channels. The communities that have already been impacted by previous lahars must remain vigilant through every rainfall event for weeks. Every dark cloud that appears over the summit is a potential trigger. Every hour of heavy rain is a calculation. Is this enough? Is this the event? 1,279 families, approximately 4,150 people, currently live within the extended hazard zone. They are not inside the 4-kilometer permanent danger zone, which was cleared of residents in previous evacuations. But they are close enough that a sudden escalation in unrest would demand immediate mass evacuation across terrain already disrupted by ashfall and lahar deposits. And here is where the planning assumptions break down. The evacuation protocols were designed around gradual escalation. Alert level 1, then level 2, then level 3. Each step giving authorities time to pre-position resources, notify communities, open evacuation centers. But Kanlaon's repeating mechanism does not follow that ladder reliably. The most dangerous phase of each cycle is the silent phase, the period of low SO2, low seismicity, and gentle inflation that precedes the explosion. There is no alert level for silence. There is no alarm that sounds when a gas reading drops. The instruments detect it, the scientists interpret it, and then they have hours, not days, to act. The plans assumed gradual escalation. Kanlaon does not do gradual. It does silent, then explosive, in under 24 hours. The human cost of this cycle has been accumulating for nearly 2 years. Since June 2024, more than 87,000 people have been displaced by Kanlaon's activity, not once, cumulatively. Across 6 eruption events, 6 rounds of evacuations, 6 cycles of displacement, and partial return and displacement again. The city of Kanlaon has absorbed $1.9 million in losses. La Castellana has lost $230,000 in agricultural damage alone. Crops buried under ash, irrigation systems choked, livelihoods suspended while the mountain decides what it wants to do next. But the economic damage figures do not capture the second-order effects. Every evacuation disrupts schooling. Every ashfall event contaminates water sources and requires communities to seal food containers and boil drinking water. Every lahar event destroys road infrastructure that took years to build. The agricultural land around Kanlaon, sugarcane, rice, vegetables, requires years to recover from heavy ash deposition. Farmers who have been displaced 3 or 4 times in 20 months are not simply waiting out an interruption. They are living through the slow erasure of the economic foundation of their communities. And above all of them, the mountain keeps cycling. This is not a volcano in decline. PHIVOLCS confirms the monitoring data shows no pronounced reduction in volcanic activity following today's eruption. Alert level 2 is maintained, and alert level 2 means more is coming. More ash emission events, more short-lived explosive bursts, more pyroclastic currents descending the flanks, more lahar risk every time the clouds open, more disruption to communities that have already absorbed more than most populations anywhere on Earth would be expected to absorb. More cycles of the same mechanism, the same silence, the same explosion. The only variable PHIVOLCS cannot pin down is timing. Kanlaon has done this before. Long before the current eruptive sequence, long before the monitoring networks and the GPS arrays and the infrasound stations, this volcano was killing people with exactly this kind of suddenness. Suddenness. In 1996, 3 mountaineers were near the summit when Kanlaon erupted without warning. They did not survive. No seismic escalation, no visible precursor that could have reached them in time. The mountain simply opened and fired. No warning. That eruption happened during a period when Kanlaon was considered to be in a relatively quiet phase. The monitoring data available at the time showed no compelling reason to believe an eruption was imminent. And then it erupted. Quiet. Now consider the current context. Kanlaon is not in a quiet phase. It is in its most sustained period of explosive activity since instrumental records began. It has erupted 6 times in 20 months. Its edifice has been inflating continuously for 4 years. Its conduit has demonstrated a repeating pattern of sealing and pressurizing. The deep magma source driving all of this has not retreated. It has been documented as growing. Explosive. The mountain does not signal its intent in ways that give comfort. It signals its intent in drops. A drop in SO2, a slight tilt in the GPS, a cluster of low-frequency earthquakes associated with gas movement. And then it erupts. Drops. The instruments caught the pattern again this time. The gas went quiet for days. The weekly average had been 752 tons per day. Then, the immediate pre-eruption period dropped to 174. The edifice had been inflating since late January. 7 low-frequency volcanic earthquakes, specifically associated with volcanic gas activity, were recorded in the hours before the blast. The data was there. Data. The data is always there. The pattern is always there. What varies is the gap between the pattern and the explosion. Sometimes that gap is wide enough to warn communities. Sometimes it is not. And the gap is shrinking. Gap. Each successive eruption in this cycle has demonstrated that Kanlaon can move from apparent stability to explosive detonation within a timeframe that challenges even the fastest institutional response. The warning systems are better than they were in 1996. The monitoring networks are denser. The seismic arrays are more sensitive. The GPS stations measure deformation in millimeters. And still, the eruption bulletin was issued 4 minutes after the explosion began. 4 minutes. That is the window. That is the distance between the data and the disaster. 4 minutes for 41 barangays and their residents to receive official confirmation of what they could already see and smell and feel. 4 minutes. This situation is still developing. The monitoring data updates every few hours. If you want to know what happens next before it becomes breaking news, subscribe. Subscribe. That is the only way this channel reaches you first. Now return to the 4 volcanoes. Mayon at alert level 3, producing thousands of pyroclastic density currents and lava flowing 3 kilometers down its eastern slope. Kanlaon at alert level 2, repeating its closed system cycle for the 6th time, its deep magma source still growing. Taal on active monitoring, 70 kilometers from Manila's urban sprawl. Bulusan temporarily quiet, but with a documented history of sudden phreatic explosions at 0 warning. This is the Philippines in February 2026. This is the Ring of Fire operating at full capacity across a single archipelago of 115 million people. Ring of Fire, full capacity. Aviation authorities have been warned to keep aircraft away from Kanlaon summit due to ash and ballistic fragments. 41 communities are cleaning ash from their streets, their roofs, their water containers. 1,279 families are watching the sky. Emergency managers are watching the drainage channels. Scientists are watching the SO2 readings and the GPS arrays, waiting to see whether the cycle resets again or whether this time something different follows. Scientists, because here is what the data cannot tell you. It cannot tell you whether the next cycle will be the same as the last 6. It cannot tell you whether the deep magma source will continue its slow intrusion, or whether it will find a new pathway. It cannot tell you whether the conduit will seal for days or for weeks before the next blast. It cannot tell you whether the next eruption will stay at the moderate level, or cross into something that demands a level 3 response and the evacuation of every community in the extended hazard zone. The data can tell you the mechanism. It can tell you the pattern. It can tell you the history. What it cannot tell you is the sentence that Kanlaon is writing will end here. The question is what the next data will look like when the gas goes quiet again. Because here on the island of Negros, surrounded by ash and lahar risk, and 4,150 people living inside the hazard zone with 3 other Philippine volcanoes on active alert and a deep magma source that has been growing for 4 years without pause, the only question left is not whether Kanlaon will do this again. The only question left is when. And whether this time, the gap between the signal and the explosion is wide enough for everyone to get out. If this data should be reaching more people, the like button is how that happens.